This lecture will cover the claim that we have two different systems by which we think. We'll start with a simple task to illustrate the idea that we have two systems by which we categorize. Since categorizing is part of thinking, this provides evidence that we have two systems by which we think. Here's the task. You'll see a series of objects on the screen. Some will be fruits, some will be vegetables. For each object you see, you call out fruit if it's a fruit, and call out vegetable if it's a vegetable. If you're in a context like riding a bus or whatever, where calling out loud fruit or vegetable would be inappropriate, you can just kind of mouth it, or you can assign a spot on your legs or something to press. So maybe your left leg would be for fruit and your right leg would be for vegetable, and you can use a finger to press your left leg if it's a fruit and your right leg if it's a vegetable. You can figure it out, but you want to respond in some way indicating fruit if it's a fruit and vegetable if it's a vegetable. So here we go. The images will go by quickly, so get ready, go. Okay, now we're going to do a very similar task, but this time you're going to call out fish if it's a fish, or not if it's not a fish, or press the appropriate spot. Okay, and finally, you're going to call out the opposite of what you see. This doesn't really work with pressing, so you'll have to maybe mouth the opposite of what you see if you can't call it out loud. Okay, so what's the point of this task? Well, let's start with the tomato. Suppose that we had you pressing a button for fruit and a button for vegetable, and we were measuring your reaction time, so how long it takes you to press the button. Even for those of you, which is probably most of you, who said fruit in response to the tomato, it would take you longer to press the fruit button for the tomato than it would for the banana or the apple. For paradigmatic fruits, you would immediately press and unhesitatingly press the fruit button. For non-paradigmatic fruits, such as a bell pepper or a tomato, it will take you longer to press the fruit button. Why is that? A tomato is a fruit just as much as a banana is a fruit, just as much as an apple is a fruit. And in some way, you know this. So if you know that a tomato is a fruit, just like a banana and an apple are a fruit, and you say fruit in response to the tomato, why does it take you longer? And the answer is that there's something inside you that wants to call this a vegetable. There's an automatic categorization system that's screaming at you pick vegetable, and you have to overcome that categorization system before you can say fruit. And even though it only takes a few hundred milliseconds, overcoming that temptation takes time. What about the manatee? Well, the point is the same. It would take you longer to press the not button for the manatee than it would for, say, the monkey. Why? Because there's something inside you that wants to call this a fish, and you have to overcome that in order to press the not button. Maybe some of you even started to say fish and then switched it up. What about the dog? Well, nearly everyone says cat as the opposite of dog. But why? In what sense is a cat the opposite of dog? What rule are you deploying to choose the opposite? Now, maybe you can come up with a rule now. You can sort of generate one. But when you chose cat as the opposite of dog, you didn't consciously deploy the rule that you may be able to come up with now. You just reacted. You just said cat. And that's because there's something inside you that has a rule for calculating opposites, has a sort of guideline for calculating opposites, and it operates independently of your conscious thought. It's not obvious that you can uncover the rule just by thinking about it. It's your brain sort of doing the categorization for you, deciding what the opposite is for you. When it comes to the train, you get a little confused. You're not sure what the opposite should be, maybe car, maybe plane, because there's many choices. So your brain needs to sort of sputter a little bit to figure it out. If you think about why the opposite of dog is cat and why the opposite of train is some other mode of transportation, you again might be able to consciously reconstruct the rule that your brain is using, but it's not your conscious reconstruction of the rule that's doing the categorization. It's some automatic processing. What about the eggplant? Well, most people say vegetable in response to the eggplant. In fact, the eggplant is a fruit for the same reason that the tomato is a fruit. So why do most people say vegetable? Well, if I ask you why do you say vegetable for the eggplant, you'll probably just say something like, because it's a vegetable. It just is. Whenever you're tempted to say it just is, or like, why is it a vegetable? Because it is, that shows that you don't have a conscious access to a rule that you're deploying to do your categorization. Your brain is kind of doing the categorization for you. Okay, we can now talk about are two systems of categorizing, which are two systems of thinking more broadly. One wants to classify tomatoes as vegetables, the other wants to classify tomatoes as fruits. It's system 1 that's telling you to say tomatoes are vegetables, and system 2 that's telling you to say tomatoes are fruits. System 1 processes information automatically. It's outside of your deliberate control. System 2, by contrast, processes information deliberately. It's the kind of processing you do when you are consciously thinking through a problem. System 1 processing produces results that just pop to mind. The word vegetable just pops to mind when you see the eggplant. By contrast, System 2 processing is the result, or conclusions are the result of willful effort. You have to do the work. Correspondingly, when you're deploying System 1 and someone asks you, why do you think that, you'll sort of either tell yourself a false story about why you think that, or be confused. You'll say, I don't know, that's just what I think. Whereas when you're doing System 2 processing, because the results, the conclusions, are from willful effort, you can in principle reconstruct the process that you went through to draw the conclusion. You can say, well, here's why I think that, and offer the reasons. System 1 computes on the basis of superficial similarity. It cares deeply about how superficially similar objects are. So it wants to classify a tomato as a vegetable because in terms of its most salient property, its basic tastes, specifically sweetness and bitterness, a tomato is more like a standard vegetable, say a carrot or an onion, than it is like a standard fruit, say a banana or an apple. That is, a tomato is, in terms of sweetness, more similar to standard vegetables than to standard fruits, and because System 1 just cares about superficial similarity, it wants to say vegetable. By contrast, System 2 can apply guidelines that may completely ignore the superficial. It can say, even though superficially, in terms of its salient feature, its profile along the basic tastes, a tomato is more similar to standard vegetables, it's still really in some deep sense a fruit, and here's why. It can look at some rules, maybe some deep, evolutionary rules, or it can have some rules like if it comes from a flower and bears its seeds internally, then it's a fruit. Whatever the rule may be, it can deploy the rule that isn't obvious on the surface. System 1 computes probabilities based on your personal stimulus history. And I'll say what that means in more detail in a moment. The basic idea is System 1 cares about what's happened to your eyes, ears, nose, and mouth, the stimulus that's been thrown at your sense organs. It doesn't care so much about facts you've read in books. By contrast, System 2 can use impersonal beliefs about frequencies. It can use facts you've read in books to draw its conclusions about what's most probable. And again, I'll say more about what I mean by this bottom contrast in a moment. System 1 is the realm of implicit processing. System 2 is the realm of explicit processing. Okay, so what do we mean when we talk about computing probabilities based on your personal stimulus history? Here's a kind of silly example to illustrate the point. Here we have a child, and she was raised on a farm on which they raise hairless cats and dogs. They have no hairy animals at all, let's say. They just have hairless cats and dogs. And we'll just talk about the dogs. Because of this, because as far as her sensory apparatus goes, dogs are hairless. That is, her System 1 associates dog with hairless. Because the stimulus that's been thrown at her eyes is pairing dog and hairless over and over, her System 1 will associate dog with hairless. Now, you can imagine she reads in a textbook that most dogs are hairy, and she believes that the textbook or the encyclopedia or whatever is true. And because of that, at the level of System 2, she draws the conclusion that if it's a dog, then it's probably hairy. So now in her mind, there's these two different systems pushing in two different directions. System 1 is going to scream if it's a dog, then it's hairless, and it's going to allow her to, it's going to associate dog with hairless, but System 2 is not. So what does this mean at the end of the day for her behavior? Well, suppose we give her a task. We're going to show her a series of animals, all different kinds of animals. And for each animal, her task is to just say whether it's a dog or not. So she either says dog if it's a dog or not if it's not. Well, when she sees a hairless dog, her System 1 and System 2 converge. They both immediately scream dog, so she just says dog. But when she sees a hairy dog, there's conflict. System 1 is saying that's not a dog, or at least it's not saying that it is. And System 2 is saying that it is a dog. So there's going to be a time delay. Notice she still says dog, but she's slower to say dog because she has to overcome System 1 before she can use System 2 to answer the question correctly. Okay, a couple of things to notice. System 1 can impact your behavior, even if it contradicts the final judgment that you make using System 2. This is like when you call the banana a fruit right away, or that child we just talked about calls the hairless dog a dog right away, but you call the tomato a fruit after some even small time delay, or the girl we just talked about calls the hairy dog a dog after some time delay. Second, System 1 can determine the judgment you make using System 2 without you even realizing it. So I ask you, what kind of object is that? You say, a vegetable. System 1 is determining the answer. Why do we think that? Well, I say to you, why is that a vegetable? You just say, it just is. Well, if you say it just is, that result is just popping to mind. It's not System 2 going through some deliberate application of a guideline or a rule to do the classification. It's System 1 doing the classification for you. Okay, so let's look at some quotes about these two systems. System 1 is the way judgments just pop into your mind and sometimes drive your behavior without you realizing it. It operates automatically and quickly with little or no effort or sense of voluntary control. This is a quote from Daniel Kahneman. He's an excellent cognitive psychologist. He actually won a Nobel Prize in economics for his work in behavioral economics. And he wrote a really nice book called Thinking Fast, Thinking Slow, which is accessible but not misleading. Sometimes authors give up on precision and accuracy to make things easier to understand. He does not do that, and yet he writes clearly enough that his book is easy to understand. There's some chapters from that book, Thinking Fast and Thinking Slow, that will be available on Canvas. System 2, by contrast, is the way you present reasoning when making it explicit, as when someone asks you, why do you think that? And you offer a clear response, offering the reasons why you think it. It, says Kahneman, allocates attention to effortful mental activities that demand it, including complex computations. It's often associated with the subjective experience of agency, so you sort of, from your point of view, realize you're doing it, choice, and concentration. Okay, we can depict this visually by thinking about what's going on in your brain in these two different cases. If you're using System 2, this is now System 2 on the left here, and someone asks you, is a dolphin a fish? You might say, well, look, here's my reason for thinking it's a fish. It's not a fish. If an animal gives birth to live young, then it's not a fish. The B stands for the animal gives birth to live young, and the F stands for it's not a fish. The second premise would say, well, a dolphin gives birth to live young, and then your conclusion would be, therefore, a dolphin is not a fish. The arrow just stands for if-then. The little symbol to the left of the F's stands for not. So if it gives birth to live young, then it's not a fish. A dolphin gives birth to live young, therefore a dolphin is not a fish. And if you're using System 2, you might say that's my reason for thinking that a dolphin is not a fish. By contrast, if you're using System 1, it's like you have a bunch of neurons in your brain or a bunch of connections, and they're all firing there. They're looking for similarity relations. That's what they care about. They're computing on the basis of your superficial superficial similarity and the stimulus that's been thrown at your sensory apparatus. They sort of do their thing, they fire around, and they spit out the answer that a dolphin is a fish. And if you did it that way, when someone asks you why, the most honest answer would be something like, because my brain said so, or my brain told me that's the answer. And your brain is just doing its computation based on your personal stimulus history and caring about superficial similarity. And again, that's System 1 level processing. Okay, so there you have a summary of the two systems side by side. You can pause there and look through it if you want to try and remember how the two systems are different. In the next segment, we're going to look at the evidence that we in fact have these two systems, and we'll first look at evidence that we have two systems for categorization, and we'll then look at evidence that we have two systems for reasoning, for drawing conclusions. Okay, we're going to stop this segment there.